Hello there, and welcome to Sleep Science, where we explore fascinating science in a quiet, relaxing way that helps your mind unwind and drift off to sleep. Before we begin tonight's gentle journey, feel free to share what time it is and where you're listening from. It's always wonderful to know where these quiet little science stories are drifting off to. Tonight, we're diving deep beneath the waves to meet one of Earth's most remarkable creatures, the orca. Black and white, graceful and powerful, these ocean wanderers are perhaps the closest thing to alien intelligence we'll find on our own planet. They speak in dialects, teach their young complex skills, and hunt with a precision that would make military strategists take notes. There's no need to follow every detail as we drift through their underwater world. Just let the gentle current of curiosity carry you wherever it will. So settle in, close your eyes if you like, and let's take a slow, peaceful dive into the extraordinary world of the orca, where family bonds run deeper than trenches and intelligence flows like the tide itself. Great white sharks flee when they hear orcas coming. It sounds like something from a marine thriller, but it's beautifully, startlingly true. The ocean's most feared predator, that legendary apex hunter with rows of razor teeth, will abandon its hunting grounds and stay away for up to a year if it encounters an orca. That tells you something profound about what we're dealing with when we talk about these black and white giants. Orcas sit at the very top of the ocean food web, and they didn't get there by accident. They're the ultimate apex predator, with no natural enemies once they reach adulthood. Nothing hunts them. Nothing threatens them. They move through the world's oceans with the quiet confidence that comes from being completely, utterly dominant. Let's talk about size for a moment, because it matters when you're trying to rule the seas. Male orcas can stretch over 9 meters long, about the length of a school bus, and weigh up to 10 metric tons. That's roughly the weight of 4 cars stacked on top of each other. All of it, muscle, blubber, and bone designed for one purpose, being the ocean's most effective predator. Females are slightly smaller, but no less impressive, and when you see one gliding through the water, there's something almost surreal about the graceful way such massive creatures move. But size alone doesn't make you an apex predator. Speed does. Orcas are the second fastest marine mammal, capable of reaching 35 kilometers per hour when they need to. Picture that, 10 tons of predator moving faster than most people drive through residential neighborhoods. Their bodies are perfectly designed for this kind of performance, cylindrical and tapering at both ends to create a hydrodynamic shape that cuts through water like a living torpedo. And when they catch you, well, that's when things get truly impressive. An orca's bite force exceeds 131 megapascals. To put that in perspective, a great white shark, the ocean's other famous predator, manages only 27.5 megapascals. Orcas bite down with nearly 5 times the force of a great white. They could, quite literally, crush a small car with their jaws. Their teeth are something to behold as well. Unlike sharks, which have rows upon rows of replaceable teeth, orcas have just 40 to 56 conical teeth that they keep for life. Each tooth is about the size of your thumb, perfectly designed for gripping rather than slicing. They don't need to slice their food into neat portions like sharks do. They're strong enough to simply hold their prey and decisive enough to know exactly what to do with it. The name killer whale comes from ancient sailors who witnessed orcas hunting other whales, and the name stuck, though it's somewhat misleading. They're not whales at all, but the largest members of the dolphin family. The scientific name, Orcinus orca, is perhaps more fitting. It derives from Orcus, the Roman god of the underworld, a reference to their reputation as harbingers of death for other marine creatures. But what truly sets orcas apart isn't their individual prowess, it's how they work together. While many apex predators are solitary hunters, orcas are deeply social. They live in family groups called pods, and these pods hunt with a coordination that borders on the supernatural. We'll explore that teamwork in detail shortly, but for now, just imagine the ocean's most powerful predator working in groups, communicating constantly, planning attacks together. This combination of individual power and collective intelligence has allowed orcas to spread across every ocean on Earth. They're found from the Arctic to the Antarctic, from coastal shallows to the deep blue expanses thousands of miles from land. They've adapted to hunt everything from small fish to massive blue whales, and they've developed specialized techniques for each type of prey. Different populations have become specialists in different kinds of hunting. Some focus on fish, particularly salmon. Others prefer marine mammals like seals and sea lions. Still others have learned to hunt other whales, including species much larger than themselves. This flexibility, this ability to adapt their hunting strategies to local conditions, is part of what makes them so successful. The fear they inspire in other creatures is both fascinating and telling. When great white sharks detect orca calls in the water, they don't just swim away. They flee the area entirely and often don't return for months. It's as if the sharks understand, on some deep level, that they've moved from being the hunter to being the hunted. Scientists have documented cases where the mere presence of orcas in an area causes dramatic changes in the behavior of other marine life. Seals become more cautious, fish schools scatter more quickly. Even other whale species alter their migration routes to avoid known orca territories. The entire ecosystem reshapes itself around these apex predators. What's perhaps most remarkable is that orcas achieved this dominance not through evolution alone, but through intelligence and culture. They learn, they teach, they innovate. Each pod develops its own hunting techniques, passed down through generations like family traditions. This means that orcas aren't just physically dominant, they're intellectually superior to most of their prey. And yet, for all their fearsome reputation, there has never been a confirmed fatal attack by a wild orca on a human. They seem to understand, somehow, that we're not prey. We're something else entirely. It's a restraint that speaks to an intelligence far beyond simple predatory instinct. So, when we call orcas apex predators, we're not just talking about their place in the food web. We're talking about creatures that have mastered their environment so completely that they've transcended the usual rules of predator and prey. They've become something more, the ocean's undisputed rulers, governing their watery realm with a combination of power, intelligence, and social sophistication that has no equal beneath the waves. Now, let's take a gentle step deeper and explore just how these remarkable hunters coordinate their attacks with a precision that would make any military strategist take careful notes. If hunting were an art form, orcas would be the ocean's greatest masters. What they do beneath the waves goes far beyond simple predation. They choreograph attacks with a precision that would make seasoned generals pause and take notes. Each hunt is a carefully orchestrated performance where every orca knows their role, timing is everything, and innovation is constantly rewarded. Let's begin with one of their most breathtaking techniques, wave washing. In the icy waters around Antarctica, some orcas have perfected a hunting method that seems almost impossible. When seals and sea lions rest on floating ice floes, thinking themselves safe from underwater predators, a pod of orcas will approach with remarkable stealth. They position themselves in a perfect line, like synchronized swimmers preparing for their most important routine. Then, working in complete unison, they swim rapidly toward the ice, creating a wave that washes right over the floe. The seal, suddenly finding itself in churning water instead of on solid ice, becomes an easy target. But here's what makes it truly extraordinary. The orcas have to calculate the size of the wave needed, the speed required to generate it, and the precise timing to coordinate their movements. One orca swimming too fast or too slow ruins the entire operation. Picture this happening in slow motion. The dark shapes moving beneath the surface, the perfectly timed surge, the wave rolling over the ice, and the seal's moment of confusion before the inevitable. It's both beautiful and humbling, a reminder that intelligence in nature takes forms we're only beginning to understand. But wave washing is just one technique in their vast repertoire. Some orca populations have mastered something called bubble net feeding, though they do it rather differently than humpback whales. They work together to create walls of bubbles that confuse and corral schools of fish. One orca swims in circles below the school, releasing a steady stream of bubbles, while others position themselves strategically around the edges. The fish, disoriented by the curtain of bubbles and unable to see clearly, are driven upward toward the surface where the waiting orcas can feast with minimal effort. The coordination required for this technique is staggering. Each orca must maintain their position, adjust their swimming speed based on the behavior of the fish, and respond instantly to changes in the school's movement. It's like a three-dimensional chess game played at high speed underwater, and they make it look effortless. Perhaps most remarkably, some orcas have learned to hunt great white sharks, not just for food, but for a very specific delicacy, the liver. They've discovered that shark liver is incredibly rich in nutrients, particularly oils that provide massive amounts of energy. But extracting a liver from a great white shark requires surgical precision and perfect timing. Here's how they do it. Working in pairs or small groups, they chase down the shark and ram it in the side with tremendous force. The impact stuns the massive predator, allowing the orcas to flip it upside down. This triggers something called tonic immobility, a natural response that essentially paralyzes the shark. While it's in this helpless state, the orcas carefully extract the liver with their teeth, leaving the rest of the shark largely untouched. The precision is breathtaking. They know exactly where to bite, how deep to go, and how to avoid damaging other organs. It's as if they have an intimate knowledge of shark anatomy passed down through generations of hunters. Scientists studying these encounters describe them as surgical in their accuracy. But perhaps the most astounding aspect of orca hunting is their ability to coordinate across distances and adapt their strategies in real time. Researchers have documented hunts involving up to 50 individual orcas, each one playing a specific role in a complex, ever-changing strategy. Some act as drivers, herding prey toward others. Some position themselves to cut off escape routes. Others wait patiently in ambush positions, ready to strike when the moment is perfect. These hunts can last for hours, with strategies shifting as conditions change. If the prey moves toward deeper water, the formation adjusts. If wind patterns alter the surface conditions, tactics are modified accordingly. It's like watching a football team that can change their entire playbook mid-game without ever breaking stride. The communication during these hunts is constant and sophisticated. The water fills with clicks, whistles, and calls as orcas coordinate their movements and share information about prey behavior. They're essentially running a military operation with real-time intelligence updates, tactical adjustments, and seamless execution. Different orca populations have developed completely different hunting specializations based on their local environment and available prey. The orcas off the coast of Argentina have learned to intentionally beach themselves to catch sea lions directly from the shore, a technique so dangerous that only a handful of individuals in each pod ever master it. Others have learned to hunt stingrays by flipping them upside down to avoid their venomous barbs. This constant innovation is what sets orcas apart from other predators. They don't just rely on instinct or physical prowess. They observe, they experiment, they learn from failure, and they pass successful techniques to the next generation. Each pod becomes a repository of hunting knowledge accumulated over decades or even centuries. The terrifying efficiency of their hunts has created ripple effects throughout marine ecosystems. When orcas arrive in an area, prey species don't just become more cautious, they fundamentally alter their behavior patterns. Migration routes change, feeding schedules shift. Entire food webs reorganize themselves around the presence of these master hunters. What's most remarkable is that despite their fearsome hunting abilities, orcas show remarkable restraint. They rarely kill more than they can eat, and they often engage in what appears to be playful behavior with potential prey, as if they're practicing techniques or simply enjoying the challenge of the hunt. This blend of lethal efficiency and intelligent restraint reveals something profound about orcas. They're not just killing machines, but thoughtful predators who understand their role in the ocean's complex web of life. They hunt with purpose, precision, and a respect for their environment that speaks to a deeper intelligence. Now, let's drift into the fascinating world of how these incredible hunters navigate and understand their underwater realm through one of nature's most sophisticated sensory systems. Orcas decided that seeing with sound was better than sound with eyes. In the murky depths where sunlight fades to nothing, where currents stir up sediment and visibility drops to mere inches, orcas navigate with a precision that puts our most advanced technology to shame. They've mastered the art of echolocation, turning the ocean into a three-dimensional map made entirely of sound. Imagine, if you will, trying to walk through your house in complete darkness, but instead of feeling your way along the walls, you could somehow paint a perfect picture of every room just by listening. That's essentially what orcas do every moment of their lives, except their house is the entire ocean, and their picture is so detailed they can tell the difference between a salmon and a tuna from 500 feet away. The magic begins in an organ called the melon, a bulbous structure in their forehead that's made of specialized fats. Think of it as nature's most sophisticated sound lens. When an orca wants to echolocate, it takes a breath, and streams of air bubble move up from the lungs through the airway. This causes two flaps called phonic lips to slap together, creating the initial sound vibrations. These vibrations travel into the melon, where something remarkable happens. The specialized fats act like a focusing lens, organizing the random clicks into a tight beam of sound. It's similar to how a flashlight focuses scattered light into a bright, directed beam, except this beam is made of high-frequency clicks that can travel through water for enormous distances. Each click lasts less than 1 millisecond, but within that tiny fraction of time, an incredible amount of information is packed. The frequencies range from 20 to 60 kilohertz, well above what human ears can detect, and the intensity can exceed 220 decibels. To put that in perspective, a jet engine produces about 140 decibels. If you could hear orca clicks at their full intensity, they would be loud enough to cause physical pain. These powerful sound beams spread through the water like invisible searchlights, bouncing off fish, rocks, the seafloor, other whales, anything solid in their path. When the sound waves hit an object, some of them reflect back toward the orca as an echo. This is where the real magic happens. The returning echoes are picked up by specialized fatty tissues in the orca's lower jaw, then conducted through bones to the middle ear and brain. But calling it simply hearing doesn't do justice to what's actually happening. The orca's brain takes these returning sound waves and transforms them into a detailed, three-dimensional image of everything around them. The precision is astounding. Orcas can distinguish between different species of fish based solely on the acoustic signature of their swim bladders. Each species has a slightly different internal structure, and those tiny differences create unique sound fingerprints that orcas learn to recognize. A Chinook salmon sounds different from a coho salmon, which sounds different from a halibut, which sounds different from a lingcod. This ability is so refined that orcas in the North Pacific, which prefer Chinook salmon above all other prey, can locate and identify their favorite fish across thousands of square miles of ocean. They're essentially searching for a specific acoustic needle in a vast marine haystack, and they find it with remarkable consistency. The range of their echolocation is equally impressive. While the exact distance varies depending on conditions, orcas can detect large objects like other whales from several miles away, and fish from distances that would be impossible to see even in the clearest water. They're effectively expanding their sensory world far beyond the limitations of light and visibility. But echolocation isn't just about finding food. Orcas use it to navigate, to map the seafloor, to locate the boundaries between different water masses, even to examine objects with a level of detail that would make an X-ray technician envious. They can determine not just the location and size of an object, but also its internal structure, density, and movement patterns. During hunts, this acoustic supersense becomes even more valuable. Orcas can track multiple fish simultaneously, predicting their movements and coordinating attacks with deadly precision. They can also use echolocation to communicate hunting information to other pod members, essentially sharing their acoustic maps in real time. The sophistication goes even deeper. Orcas can adjust the intensity and focus of their clicks based on what they're trying to accomplish. When scanning large areas for prey, they might use broad, powerful clicks that cover maximum range. When examining something up close, they switch to quieter, more focused clicks that provide incredible detail without overwhelming their sensitive hearing. Perhaps most remarkably, they can control multiple aspects of their echolocation simultaneously. The direction of the beam, the frequency of the clicks, the intensity of the sound, and the timing between clicks. It's like being able to independently adjust the zoom, focus, brightness, and frame rate of a camera while also controlling where it points, all through pure thought. This level of acoustic mastery has implications beyond just hunting and navigation. Some scientists believe that orcas may use echolocation to examine the internal state of other orcas, possibly detecting emotional states, health conditions, or even pregnancy by reading the subtle acoustic signatures of their podmates' bodies. The underwater world, as experienced by an orca, must be a rich tapestry of acoustic information, constantly flowing and changing. Where we might see only dark water, they perceive a detailed landscape painted in sound, full of moving objects, hidden dangers, and opportunities that exist in a sensory dimension we can barely imagine. Their mastery of echolocation represents millions of years of evolution, fine-tuning one of nature's most sophisticated sensing systems. It's a reminder that intelligence comes in many forms, and that the natural world contains technologies that we're still struggling to understand, let alone replicate. But there's something even more profound about these acoustic masters that goes beyond their technical abilities, something that touches the very heart of what it means to be conscious and feeling. Grief, it seems, is not uniquely human after all. In the summer of 2018, the world watched as an orca mother named Tahlequah carried her dead calf for 17 days, pushing the tiny body through the waters of the Pacific Northwest with her rostrum and balancing it on her back. For over 1,000 miles, she refused to let go, supported by her pod in a journey that can only be described as a funeral procession. This wasn't an isolated incident. Orcas have been observed carrying their deceased young for days or even weeks, supported by family members who bring them food and swim protective formations around them. Its behavior so recognizably emotional, so unmistakably similar to human mourning, that it challenges everything we thought we knew about the inner lives of marine mammals. But grief is just one note in the rich symphony of orca emotions. These creatures experience joy with an exuberance that's both infectious and humbling. Watch a pod of orcas at play, and you'll see them leaping completely out of the water in perfect synchrony, their massive bodies defying gravity for brief, joyful moments. They play catch with kelp, tossing long ribbons of seaweed back and forth like children with a ball. They body surf on waves, ride the wake of boats, and engage in elaborate games of tag that can last for hours. There's something deeply moving about watching an orca at play. These are apex predators, perfectly designed killing machines, choosing to spend their time in pure, uncomplicated fun. Young calves will playfully bother their mothers, nudging and splashing until the adults join in the games. Teenagers, if we can call them that, engage in the kind of rough and tumble play that would look familiar to any parent watching children in a playground. The emotional bonds within orca families run deeper than almost any other animal relationship we know. Male orcas stay with their mothers for their entire lives, which can span 70 to 90 years. These aren't just loose associations, but genuine emotional partnerships. Mothers will share food with their adult sons, protect them during conflicts, and help care for their grandchildren. When a matriarch dies, the impact on the family is profound and measurable. Her offspring show increased signs of stress, their health often deteriorates, and the family's social structure can take years to recover. Scientists have documented what can only be called empathy among orcas. They've seen healthy adults supporting injured pod members at the surface so they can breathe. They've observed orcas sharing food with those too young, old, or weak to hunt effectively. In captivity, orcas have been seen comforting distressed poolmates, positioning themselves nearby and making gentle vocalizations that seem designed to provide reassurance. Perhaps most remarkably, orcas show emotional responses to the distress of other species. There are documented cases of orcas protecting other marine mammals from shark attacks, gently supporting struggling sea lions at the surface, and even attempting to help stranded whales return to deeper water. This kind of interspecies empathy suggests an emotional sophistication that we're only beginning to understand. Their play behaviors extend beyond simple physical games to what can only be described as creativity and humor. Orcas have been observed creating their own entertainment. Some populations play with floating objects they find in the ocean. Others deliberately create whirlpools just for the apparent pleasure of swimming through them. They seem to enjoy surprising each other, popping up unexpectedly beside pod mates, or creating sudden splashes to startle their companions. The emotional complexity becomes even more apparent when we look at their responses to captivity. Orcas in marine parks display behaviors never seen in the wild: repetitive swimming patterns, aggression toward trainers, self-destructive behaviors, and what can only be described as depression. Their dorsal fins collapse, their lifespans shorten dramatically, and their social behaviors become distorted. It's as if their emotional needs are so complex that artificial environments simply cannot satisfy them. In the wild, emotional expression seems to be deeply woven into their communication. Different calls appear to be associated with different emotional states. Excited vocalizations during successful hunts sound markedly different from the gentle murmurs exchanged between mothers and calves. The long, haunting calls that carry across miles of ocean often seem to express something like longing or loneliness, though we can only guess at their true meaning. Their emotional intelligence extends to what appears to be a sense of fairness and justice. In multi-generational pods, conflicts are typically resolved through complex social negotiations rather than simple dominance displays. Older females often act as mediators in disputes, and there seems to be an understanding of reciprocity, shared responsibility, and mutual aid that governs their social interactions. What's perhaps most moving is how orcas seem to understand death and loss in ways that parallel our own experiences. They've been observed visiting places where family members died, sometimes years after the fact. They show clear signs of distress when separated from loved ones, and their reunion behaviors, filled with excited vocalizations and physical contact, speak to emotional bonds that endure across time and distance. The neurological basis for these emotions lies in an extraordinarily developed insular cortex, the brain region associated with empathy, self-awareness, and emotional processing. In orcas, this region is more developed than in any other animal, including humans. It suggests that their emotional experiences might be even richer and more complex than our own. This emotional sophistication forces us to reconsider what we mean when we talk about consciousness, about the inner lives of other species, about the nature of intelligence itself. Orcas don't just think and solve problems, they feel deeply, love fiercely, and mourn genuinely. They experience the full spectrum of emotions that we consider fundamental to being conscious, aware beings. As we drift deeper into understanding these remarkable creatures, we discover that their emotional complexity is matched only by the physical complexity of the organ that makes it all possible. A brain so intricately folded, it rivals the most elaborate origami. An orca's brain has more folds than an origami master's finest work. Inside that massive black and white head sits what might be the most complex thinking organ on Earth, a 6-kilogram universe of neural tissue so intricately folded that it makes human brains look relatively smooth by comparison. When scientists first examined orca brains under microscopes, they found themselves staring at something that challenged every assumption about intelligence, consciousness, and what it means to think. Let's begin with the simple matter of size. Though nothing about orca brains is actually simple. At up to 6.8 kilograms, an orca brain is the second largest in the animal kingdom, outweighed only by sperm whales. But size alone doesn't tell the story of intelligence. After all, elephants have larger brains than humans, but we don't consider them more intelligent than us. What matters more is the relationship between brain size and body size, a ratio that scientists call the encephalization quotient. Here's where things get interesting. Humans lead the pack with an encephalization quotient of about 7, meaning our brains are 7 times larger than you'd expect for a mammal of our body size. Bottlenose dolphins come in second at around 4. And orcas? They score about 2.5, putting them in remarkable company among the most intelligent creatures on Earth. But the real magic lies not in size, but in surface area. If you could somehow unfold an orca brain and lay it flat, you'd be amazed by how much surface area is packed into that skull. This is possible because of something called gyrification, the folding and wrinkling of the brain's outer layer, the cerebral cortex. These folds and wrinkles aren't random. They're the brain's elegant solution to fitting more processing power into a limited space. Think of it like trying to fit a large piece of paper into a small box. You could crumple it up randomly, but you'd waste space and create chaos. Instead, if you folded it neatly and systematically, you could fit much more paper into the same space while keeping everything organized and accessible. That's essentially what evolution has done with the orca brain. The degree of folding in an orca brain is measured by something called the gyrification index, and here's where orcas truly stand apart. Humans have a gyrification index of 2.2. Bottlenose dolphins, already impressive, score 5.6. But orcas? They reach 5.7, the highest gyrification index of any brain ever measured. Their brains are the most folded, most wrinkled, most intricately organized thinking organs in the known world. What does all this folding accomplish? More surface area means more neurons, more connections, more processing power. It's like upgrading from a simple calculator to a supercomputer. The folded cortex of an orca brain can handle vastly more information, make more complex associations, and support more sophisticated thinking than a smooth brain of the same size. But perhaps the most fascinating structure in the orca brain is the insular cortex, a region associated with some of the most profound aspects of consciousness, self-awareness, empathy, emotional processing, and social cognition. In humans, the insular cortex lights up when we feel compassion, when we recognize ourselves in a mirror, when we understand that we are distinct individuals with our own thoughts and feelings. In orcas, the insular cortex is extraordinarily developed, more so than in any other animal, including humans. This suggests that orcas may experience self-awareness and empathy at levels we can barely comprehend. They don't just think, they think about thinking. They don't just feel, they understand that they feel, and they can imagine how others might feel too. This neural architecture has been put to the test in fascinating ways. In 2001, researchers conducted mirror self-recognition tests with orcas, a classic assessment of self-awareness. They placed mirrors in front of orcas and marked parts of their bodies with harmless but visible substances. The question was simple: would the orcas recognize that the reflection was themselves, not another orca? The results were remarkable. When the orcas saw their marked reflections, they became intensely interested in the markings. They positioned themselves to get better views, blew bubbles at their reflections, bobbed their heads, and stuck out their tongues. These behaviors were unusually frequent and lasted much longer than normal interactions with mirrors, suggesting that the orcas understood they were looking at themselves. This kind of self-recognition requires a sophisticated understanding of the concept self. It means orcas have a mental model of their own bodies, can recognize when something about their appearance has changed, and understand that the image in the mirror represents them, not another individual. It's a cognitive achievement that only a handful of species have demonstrated: great apes, elephants, dolphins, and now orcas. The implications are profound. Self-awareness is often considered the foundation of consciousness as we understand it. If orcas can recognize themselves, it suggests they have rich inner lives, complete with self-reflection, introspection, and perhaps even something like what we might call a sense of identity. Their neural complexity extends to memory systems as well. Orcas have been observed returning to specific locations years or even decades after significant events occurred there. They remember the calls of individuals they haven't encountered for years. Matriarchs serve as living libraries of ecological knowledge, remembering the locations of food sources, the patterns of seasons, the behaviors of prey species across decades of experience. The combination of massive size, extreme folding, and specialized structures creates a brain capable of processing information in ways we're only beginning to understand. It's a neural architecture that supports not just survival, but culture, creativity, empathy, and consciousness. When we look into an orca's eye, we might be looking into a mind as complex and aware as our own, but organized in ways that reflect 50 million years of aquatic evolution. This extraordinary brain didn't develop overnight. It's the product of an epic evolutionary journey that began long ago, when the ancestors of these magnificent creatures walked on 4 legs across ancient landscapes. Once upon a time, whales had legs and a very different view of the ocean. 50 million years ago, Long before orcas ruled the seas, their ancestor was a four-legged, wolf-sized creature called Pachycetus that lived along the edges of shallow seas in what is now Pakistan. It had fur, it breathed air, and it walked on land. Yet within its bones and teeth were the first hints of a transformation that would eventually produce the ocean's most sophisticated predators. Pachycetus lived a life that straddled two worlds. During the day, it hunted small mammals and scavenged along the shoreline. But when hunger called, it wasn't afraid to wade into the water to catch fish and other marine creatures. Its elongated skull and specialized teeth were already showing adaptations for an aquatic diet. Its ears had begun to change in ways that would eventually allow for underwater hearing. Evolution, it seems, was quietly preparing for one of the most dramatic transformations in the history of life. Imagine the world as it existed then. The climate was warmer, sea levels were higher, and vast shallow seas covered much of what is now dry land. For a creature like Pachycetus, these waters represented opportunity, abundant food sources, fewer terrestrial competitors, and new ecological niches waiting to be filled. Over millions of years, some of its descendants began spending more and more time in the water, gradually trading the solid ground for the buoyant embrace of the sea. The fossil record tells us this transition didn't happen overnight. It took about 8 million years for these early whale ancestors to fully commit to aquatic life. During this time, they underwent one of the most remarkable transformations in evolutionary history. Legs slowly became flippers. Nostrils migrated from the tip of the snout toward the top of the head, eventually becoming the blowholes we see today. Bodies became streamlined. Fur was replaced by blubber. But perhaps most remarkably, their brains began to change. The neural structures needed for echolocation started to develop. The social intelligence required for complex group living began to emerge. The cognitive abilities that would eventually allow for culture, language, and consciousness slowly took shape. They weren't just changing physically, they were becoming fundamentally different kinds of thinking beings. Even today, orcas carry reminders of their terrestrial origins. Inside their flippers, if you look carefully at the bone structure, you can still see the remains of what were once fingers. There are arm bones, wrist bones, and even individual finger bones, all compressed and modified for swimming, but still recognizably similar to the limbs of land mammals. It's like finding the skeleton of a hand inside a flipper, a fossil record written in living bone. Perhaps even more telling are the vestigial pelvic bones buried deep in an orca's body. These small, seemingly useless bones serve no purpose in a creature that propels itself with its tail flukes. They can't support weight or assist in locomotion. They're simply evolutionary leftovers, remnants of the hip bones that once connected powerful leg muscles to the spine. Every orca carries within its body the ghost of legs it no longer needs. The transition from land to sea required innovations that still seem almost magical. Early whales had to solve the problem of breathing while spending most of their time underwater. They developed the ability to consciously control their breathing, something most mammals do automatically. They learned to slow their heart rates during dives, to store extra oxygen in their blood and muscles, to withstand the crushing pressures of the deep. Their sensory world transformed completely. On land, Pachycetus would have relied heavily on smell and sight. But underwater, these senses become much less useful. Instead, whales developed echolocation, turning sound into their primary sense for navigating and hunting. They created a sensory experience unlike anything terrestrial mammals had ever known. As millions of years passed, these aquatic mammals diversified into the incredible variety of whales and dolphins we see today. Some, like blue whales, became gentle giants that filter feed on tiny krill. Others, like sperm whales, became deep-diving specialists hunting squid in the ocean's darkest depths. And some, like the ancestors of modern orcas, became the apex predators we know today. Orcas belong to the dolphin family, Delphinidae, which makes them the largest dolphins rather than true whales. This family tree includes bottlenose dolphins, pilot whales, and dozens of other species, all descended from those early aquatic pioneers. But orcas represent something special within this family. They became the ultimate marine predator, combining size, intelligence, and social sophistication in ways that allowed them to hunt prey much larger than themselves. The evolutionary journey from Pakicetus to modern orcas represents one of the most successful adaptations in the history of life. These creatures didn't just learn to survive in the ocean, they mastered it completely. They developed hunting strategies more sophisticated than those of any terrestrial predator. They created social structures more complex than most land mammals. They evolved intelligence that rivals our own. What's most remarkable is that this transformation required not just physical changes, but cognitive ones. The brain that could navigate three-dimensional ocean spaces was fundamentally different from one designed for flat terrestrial landscapes. The social intelligence needed for coordinated pod hunting was unlike anything required for solitary land predation. The communication systems necessary for long-distance underwater coordination had no terrestrial equivalent. In many ways, the evolution of orcas represents a second genesis, a reimagining of what it means to be an intelligent, social mammal in an entirely different environment. They took the basic mammalian blueprint and redesigned it so thoroughly that the result was something genuinely new, a creature equally at home in the ocean's depths and at its surface, capable of complex thought and emotion, bound together by social bonds that would put most human families to shame. And it's those family bonds that we turn to next. Relationships so deep and enduring, they reshape our understanding of what it means to belong. Growing up in an orca family means never really leaving home. In a world where most mammals eventually strike out on their own, orcas have chosen a different path entirely. They've built their entire society around the idea that family bonds should last forever, creating some of the strongest and most enduring relationships in the animal kingdom. At the heart of every orca family is a matriarch, usually the oldest female in the group. She's not just the leader, she's the living memory of the pod, the keeper of knowledge accumulated over decades of life in the ocean. She remembers where to find salmon during lean years, which currents to follow during migrations, where the dangerous waters lie, and how to navigate through the changing seasons. Her knowledge isn't just useful, it's essential for the survival of her entire family. This isn't a temporary arrangement that lasts until the young grow up. Male orcas, no matter how large or powerful they become, will follow their mothers for their entire lives. A 30-year-old bull, fully capable of living independently, will still swim alongside his mother, still defer to her judgment, still benefit from her wisdom. If she lives to be 80 or 90, he'll be there beside her, a middle-aged son who never left home and never needed to. The structure of orca families is beautifully complex. A typical pod consists of a matriarch and her children, grandchildren, and sometimes even great-grandchildren. Multiple generations swim together in perfect harmony, each member knowing exactly where they fit in the family constellation. It's like a multi-generational household that travels together across thousands of miles of ocean, sharing meals, protecting each other, and passing down the accumulated wisdom of their lineage. What makes this system work is the role of the grandmothers. In many animal societies, older females who can no longer reproduce become burdens on the group. But in orca society, post-reproductive females become more valuable than ever. They're the ones with the most knowledge, the most experience, the deepest understanding of their environment. They become teachers, guides, and wisdom keepers for the entire extended family. Research has shown that pods led by older matriarchs have higher survival rates, especially during difficult years when food is scarce. These experienced females remember events that happened decades ago, where the salmon ran during the drought of 1977, how the pod survived the harsh winter of 1983, which hunting strategies work best when prey is scarce. This institutional memory, passed down through generations, gives their families crucial advantages in an unpredictable world. The grandmother effect is so strong in orcas that it may have actually driven the evolution of menopause. Orca females typically stop reproducing in their 40s, but they can live for decades afterward. During these post-reproductive years, they focus entirely on helping their children and grandchildren survive and thrive. It's a biological investment in the success of the family line that goes far beyond simply producing offspring. Child rearing in orca society is a cooperative effort that would put many human communities to shame. When a calf is born, it becomes the responsibility of the entire pod. Aunts and older siblings help care for the young one, teaching it how to hunt, how to communicate, how to navigate the complex social dynamics of family life. Multiple adults will position themselves protectively around a calf during dangerous situations, and nursing mothers often share their milk with calves that aren't their own. The bonds formed during these early years last a lifetime. Siblings who grow up together remain close throughout their lives, supporting each other through challenges, celebrating successes together, and maintaining relationships that span decades. Brothers and sisters will coordinate hunts, share food, and provide emotional support to each other long into their adult years. Perhaps most remarkably, these family bonds extend to conflict resolution and emotional support in ways that mirror human families. When disputes arise within the pod, older females often serve as mediators, using their experience and authority to restore harmony. When a family member is injured or distressed, others will gather around to provide comfort and assistance. They've been observed gently supporting wounded family members at the surface to help them breathe, sharing food with those too weak to hunt, and staying close to provide emotional comfort during times of stress. The depth of these emotional bonds becomes most apparent during times of loss. When a matriarch dies, the impact on her family is profound and long-lasting. Her children and grandchildren show clear signs of grief, their health often deteriorates, and the family's social structure can take years to reorganize. It's as if the emotional foundation of their world has shifted, leaving everyone struggling to find their new place in the family constellation. But it's not just loss that reveals the strength of their bonds. Reunions after periods of separation are marked by intense excitement, with family members rushing toward each other, vocalizing enthusiastically, and engaging in extended physical contact. The joy of these reunions is unmistakable, suggesting that orcas not only form deep attachments, but actively miss each other when they're apart. This emphasis on family extends to decision-making as well. Orca pods operate more like democracies than dictatorships. While the matriarch's wisdom is deeply respected, major decisions about where to travel, when to hunt, and how to respond to threats are often made collectively, with input from multiple family members. It's a system that values both experience and consensus, ensuring that everyone's voice is heard while still benefiting from accumulated wisdom. The social structure of orca families challenges many assumptions about intelligence and emotion in the animal world. These are creatures who have chosen cooperation over competition, wisdom over strength, and family bonds over individual success. They've created a society where the elderly are revered rather than abandoned, where children are raised by entire communities, and where family relationships provide both practical benefits and deep emotional satisfaction. In a world where family bonds often seem fragile and temporary, orcas offer a different model, one where love, loyalty, and mutual support create the foundation for not just individual success, but the flourishing of entire communities. Their families aren't just social groups, they're networks of care, knowledge, and belonging that span generations and cross the vast expanses of the sea. Now, let's drift into the remarkable ways these close-knit families communicate, sharing stories and songs that echo across the depths in languages as complex as our own. In the beginning was the word, and in the ocean, that word was whale song. Long before humans discovered that sound could carry meaning across vast distances, orcas were already speaking to each other in voices that could travel for miles beneath the waves. They had developed something that scientists are only now beginning to understand: a complex, learned language as sophisticated as any human tongue, passed down through generations like an underwater oral tradition. The discovery of orca language began in the 1970s, when researchers first lowered hydrophones into the waters of the Pacific Northwest and listened to what was happening below the surface. What they heard changed everything we thought we knew about animal communication. The ocean wasn't silent at all. It was filled with conversations, arguments, lullabies, and stories told in voices that ranged from gentle whispers to thunderous calls that could shake the very foundations of the sea. Scientists quickly realized that orcas use three distinct types of vocalizations, each serving a different purpose in their complex social lives. The first sounds they identified were clicks, rapid-fire bursts of sound that create what researchers call click trains. These aren't random noises, but precisely controlled acoustic tools used for echolocation. When hunting, an orca's click train becomes a constant stream of information, mapping the underwater world in real time and sharing that acoustic picture with family members swimming nearby. But clicks are just the beginning. Orcas also produce whistles, high-pitched sounds that don't carry far through water but serve as intimate, close-range communication between pod members. Think of whistles as whale whispers, private conversations shared between family members when they want to coordinate without alerting prey or other orcas to their plans. These sounds are highly directional and modulated, like underwater sign language spoken in frequencies that can extend into ranges humans can't even hear. The most remarkable sounds, however, are the calls. These are the voices that carry across miles of ocean, as loud as jet engines and just as impossible to ignore. Orca calls are complex, pulsed vocalizations that show sudden shifts in frequency and pattern. They're the public announcements of the underwater world, declaring identity, location, and intent to anyone within listening range. What makes orca language truly extraordinary is that it's learned, not inherited. When a calf is born, its first vocalizations are nothing like adult orca calls. Instead, they make loud, high-pitched screams that bear no resemblance to the sophisticated communication they'll eventually master. It's remarkably similar to how human babies babble before learning to speak. The calf must listen, practice, and gradually learn the specific dialect of its family pod. Each orca family speaks its own unique dialect, a collection of calls that can be as distinctive as regional accents in human languages. These dialects are so specific that researchers can identify which pod an orca belongs to just by listening to its vocalizations. One group might use calls that begin with low pulse bursts, followed by rising tones. Another family might prefer completely different patterns, gradual rises followed by sudden frequency shifts and ending with low-pitched bursts. What's truly remarkable is how stable these dialects remain over time. Researchers studying the same pods for decades have found that family calling patterns remain essentially unchanged for generations. It's as if each pod has developed its own family language, passed down from grandmother to calf like an heirloom that never loses its value. The difference between resident and transient orcas becomes even more apparent when we listen to their languages. Resident orcas, those fish-eating families that stay in predictable areas, are remarkably vocal. Their underwater world is filled with constant chatter, hunting calls, family check-ins, social commentary, and what can only be described as casual conversation. They seem to talk almost constantly, maintaining audio contact with family members spread across miles of ocean. Transient orcas, those marine mammal hunters who roam unpredictably across vast distances, have chosen a very different approach to communication. They're remarkably quiet, often hunting in complete silence to avoid alerting their prey to their presence. When they do vocalize, it's usually with one specific type of call, a long, quiet, low-frequency sound that carries far underwater but doesn't give away their location to potential prey. The complexity of orca communication has captured the attention of artificial intelligence researchers who believe they may be on the verge of a breakthrough. Using machine learning algorithms, scientists are processing hundreds of hours of orca vocalizations, looking for patterns, recurring elements, and possible meanings. They're training AI systems to identify different call types, find possible subunits within calls, and detect recurring communication patterns that might reveal the structure of orca language. The goal is ambitious, but not impossible: to create a translation system that could allow meaningful communication between humans and orcas. Recent advances in AI have shown that computers can learn to translate between human languages without any prior knowledge of grammar or vocabulary, simply by analyzing patterns in large datasets. Applying similar techniques to orca vocalizations might eventually allow us to decode their underwater conversations. Imagine the implications if we could actually understand what orcas are saying to each other. We might learn about their experiences, their emotions, their knowledge of the ocean that spans generations. We might discover that their calls contain detailed information about hunting strategies, family histories, or environmental changes that we've never considered. But perhaps the most profound aspect of orca language is what it reveals about their inner lives. The fact that they have learned, culturally transmitted communication systems suggests that they have something meaningful to communicate about. They're not just responding to immediate needs or instincts. They're sharing complex information, maintaining social relationships, and possibly even telling stories about their experiences. Their language becomes the foundation for everything else that makes orcas remarkable: their hunting coordination, their family bonds, their cultural traditions. Without the ability to share complex information across generations, their sophisticated societies would be impossible. Language doesn't just allow them to communicate, it allows them to be the remarkable, intelligent, social creatures that continue to astonish and humble us. As we listen to their songs echoing through the depths, we're hearing more than just animal communication. We're hearing the voices of beings with rich inner lives, complex societies, and stories that stretch back through millions of years of ocean wisdom. Orcas invented culture long before humans thought to write anything down. While we were still learning to make fire and chipstones into tools, orcas had already developed complex societies with their own traditions, customs, and ways of life that varied dramatically from one community to another. They created something that scientists once thought was uniquely human. Cultures so distinct that neighboring pods living in the same waters might as well be from different worlds entirely. The most striking cultural divide exists between what researchers call resident and transient orcas. Though they're the same species and often share the same waters, these two groups live completely different lives, speak different languages, eat different foods, and follow entirely different social rules. It's as if two human communities had evolved such different ways of life that they could barely recognize each other as the same species. Resident orcas are the homebodies of the orca world. They live in relatively predictable locations, often staying within a few hundred miles of familiar coastlines for their entire lives. Their pods are large, sometimes including 40 or 50 individuals across multiple generations. They're remarkably social, constantly vocalizing and staying in close contact with family members. Their entire culture revolves around fish, particularly salmon, and they've developed elaborate cooperative hunting strategies that can involve dozens of individuals working together like an underwater symphony. These resident communities have stable, complex social hierarchies where older females hold positions of respect and authority. They practice something that looks remarkably like education, with experienced adults teaching young orcas the specific hunting techniques that their particular pod has perfected over generations. Different resident pods have developed different specializations. Some are expert herring hunters, others focus on salmon, and each group has its own collection of proven strategies. Transient orcas live by entirely different rules. They're the nomads of the orca world, traveling enormous distances with no fixed territories or predictable routes. Some pods of transients are known to journey from Alaska to California, covering thousands of miles in pursuit of their preferred prey, marine mammals. Their pods are much smaller, typically just 3 or 4 individuals, and they maintain much looser social structures. Perhaps most remarkably, transients have developed a culture of silence. While residents chatter constantly, transients often hunt in complete quiet, using their intelligence and coordination without the constant vocal communication that characterizes resident life. They've learned that marine mammals have excellent hearing and can detect orca calls from great distances. So they've culturally adapted to hunt using visual cues, body language, and an almost telepathic level of coordination. The cultural differences extend to their treatment of other species. Residents and transients living in the same waters will completely ignore each other, as if they belong to different worlds. They don't interbreed, don't share hunting grounds, don't even acknowledge each other's presence. It's a level of cultural isolation that's almost unprecedented in the animal world. But perhaps the most remarkable example of orca culture comes from the waters off Argentina, where a small group of orcas has developed one of the most dangerous and sophisticated hunting techniques ever documented. They've learned to intentionally beach themselves to catch sea lions directly from the shore, a behavior so risky and complex that only a handful of individuals in the entire population have ever mastered it. This technique, called intentional stranding, requires years of training and practice. Young orcas spend months or even years learning to time their approach with incoming waves, to calculate the exact speed and angle needed to slide onto the beach, and most critically, to arch their bodies and rock sideways to catch the next wave back to deeper water. It's like learning to surf, except the consequences of failure can be death. The teaching process is remarkable to witness. Adult females, always the teachers in orca society, will practice with young orcas for hours at a time. They'll bring props like pieces of kelp to help the youngsters understand the mechanics of grabbing and holding prey. They'll demonstrate the technique repeatedly, showing exactly how to approach the beach, how to position their bodies, and how to escape back to safety. Not every young orca succeeds in learning this technique. Some become too frightened by the sensation of being stranded and never try again. Others lack the precise timing and coordination required. Only about 13 of the 30 orcas in this population have ever mastered intentional stranding, making it one of the most exclusive skills in the animal kingdom. What makes this cultural behavior even more remarkable is that it's been documented for nearly 40 years, meaning it's being passed down across generations. Grandmothers teach mothers, mothers teach daughters, and the tradition continues unbroken despite its obvious dangers. It's become part of the cultural identity of this particular orca community, a skill that defines them as distinct from all other orcas in the world. The cultural differences between orca populations are so profound that scientists believe they may actually be driving evolution. Just as human cultural practices have influenced our physical evolution, orca cultures may be slowly creating genetic differences between populations. The transient and resident orcas of the Pacific Northwest are already so genetically distinct that some researchers believe they're on the path to becoming separate species entirely. This would make orcas one of the only animals whose evolution is being driven by culture rather than just environmental pressures. Their different ways of life, their distinct hunting strategies, their separate social structures, and their different communication systems are creating reproductive isolation that could eventually lead to biological speciation. The implications are profound. It suggests that orcas, like humans, have reached a point in their evolution where cultural change happens faster than genetic change. They can adapt to new environments, develop new technologies, and solve new problems not by waiting for favorable mutations, but by learning, teaching, and passing down innovations through their communities. In watching orca cultures develop and persist across generations, we're witnessing something extraordinary: the evolution of intelligence itself, playing out in real time beneath the waves. These creatures have shown us that culture isn't uniquely human, that learning and teaching can shape entire societies, and that intelligence, when combined with strong social bonds, can create traditions that last for generations. Teamwork, it turns out, reaches its finest expression underwater. While humans often struggle to coordinate simple group activities, orcas have elevated cooperation to an art form that spans species, crosses generational lines, and creates partnerships that challenge everything we thought we knew about intelligence and collaboration in the natural world. The most remarkable discovery in recent years has been the documentation of orcas working together with humpback whales, species that in other circumstances might be predator and prey. In the waters off Norway, researchers have captured footage of something that seems almost impossible: orcas and humpbacks coordinating their efforts to hunt massive schools of herring, each species contributing their unique abilities to create a hunting strategy more effective than either could accomplish alone. Picture this extraordinary scene: humpback whales using their enormous size to corral fish into tight balls, while orcas use their speed and agility to prevent escape. The humpbacks create vertical walls of whale body, essentially forming living barriers that the fish cannot penetrate. Meanwhile, the orcas dart back and forth, plugging gaps and driving stragglers back into the concentrated school. When the fish are perfectly positioned, both species feed together, sharing the bounty of their collaborative effort. This interspecies cooperation requires a level of communication and mutual understanding that we're only beginning to comprehend. The two species must somehow coordinate their movements, timing, and strategies despite speaking completely different languages and having vastly different hunting traditions. It suggests a form of intelligence that transcends species boundaries, a recognition that sometimes the greatest success comes from working with others, even those who are fundamentally different from yourself. But cooperation among orcas themselves reaches even greater heights of sophistication. Within pods, the division of labor during hunts resembles a perfectly choreographed performance where every individual knows their role without needing explicit direction. Some orcas serve as scouts, using their superior echolocation abilities to locate and assess potential prey. Others act as drivers, herding fish or marine mammals toward predetermined ambush points. Still others position themselves as blockers, cutting off escape routes and ensuring that prey cannot flee to deeper water or safer areas. The coordination extends beyond simple positioning. Orcas have been observed taking turns during extended hunts, with some individuals resting while others maintain pressure on prey. They share information constantly throughout these hunts, using their complex vocalizations to communicate changes in prey behavior, environmental conditions, and tactical adjustments. It's like watching a football team that can change their entire strategy mid-play without ever breaking formation. Perhaps most remarkably, orcas demonstrate what can only be called fair play during these cooperative hunts. Despite their ability to dominate through size and strength, they typically ensure that all pod members get adequate food, with adults often giving way to allow juveniles and elderly family members to feed first. Mothers have been observed catching fish and then releasing them near their calves, providing easy hunting opportunities for youngsters still learning the necessary skills. The teaching aspect of orca cooperation is equally fascinating. During hunts, experienced adults will deliberately slow down their attack patterns to allow young orcas to practice and learn. They'll position themselves to guide inexperienced hunters into better positions, and they'll even intervene to prevent young orcas from making potentially dangerous mistakes. It's a form of hands-on education that requires remarkable restraint and patience from apex predators who could easily complete hunts much more quickly and efficiently on their own. Conflict resolution within cooperating groups showcases another dimension of orca social intelligence. During complex hunts involving multiple family groups, disputes occasionally arise over feeding order, positioning, or tactics. Rather than allowing these conflicts to disrupt the hunt, orcas have developed sophisticated methods for resolving disagreements quickly and fairly. Older females often serve as mediators, using their authority and experience to restore harmony and keep the group focused on their shared objective. The cooperative behaviors extend far beyond hunting into virtually every aspect of orca social life. They engage in cooperative childcare, with multiple adults taking responsibility for protecting and educating young pod members. They practice cooperative defense, with healthy adults positioning themselves to protect injured or vulnerable family members. They even engage in cooperative play, with entire pods participating in elaborate games that seem designed to strengthen social bonds and maintain group cohesion. One of the most moving examples of orca cooperation involves their response to distressed pod members. When an orca is injured, sick, or dying, other pod members will often form protective circles around them, supporting them at the surface to help them breathe and staying with them for hours or even days. These vigils require tremendous energy and coordination from multiple individuals, all working together to provide comfort and protection to a family member in need. The cooperative behaviors also extend to communication and information sharing. Orcas have been observed sharing hunting knowledge across family groups, with successful hunting techniques spreading from pod to pod through what appears to be deliberate teaching and demonstration. It's as if they have informal universities where innovations and improvements are shared for the benefit of the entire community. Recent research has revealed that cooperation among orcas involves not just immediate family members, but extends to distant relatives and even unrelated individuals within the same population. During times of scarce food or environmental stress, multiple pods will sometimes join forces, creating superpods of hundreds of individuals, all working together toward common survival goals. This level of cooperation requires cognitive abilities that we're only beginning to understand. The ability to recognize individual contributions, to maintain fairness over time, to coordinate complex activities across large groups, and to balance individual needs with collective benefits. It suggests that orcas have developed social intelligence that in many ways surpasses our own, creating societies where cooperation isn't just beneficial but fundamental to their entire way of life. In watching orcas work together, we see a model of what's possible when intelligence, empathy, and social bonds combine to create something greater than the sum of its parts. They've shown us that the highest expressions of intelligence might not be individual achievements, but collaborative ones that bring out the best in everyone involved. Imagine never being able to breathe without thinking about it. Every single breath you take for the rest of your life requires a conscious decision, a deliberate choice to swim to the surface and fill your lungs with air. This is the reality for every orca, every moment of every day. They're mammals like us, dependent on oxygen, but they've chosen to live in a world where that life-giving air exists only at the boundary between two worlds. This fundamental challenge, being an air-breathing animal in an aquatic environment, has shaped every aspect of orca biology and behavior. Unlike fish, which can extract oxygen directly from water through their gills, orcas must return to the surface regularly to breathe. It's a constraint that would seem to limit their options, but instead, it's become one of the most remarkable examples of evolutionary adaptation in the natural world. The solution begins with conscious control. While you breathe automatically, your respiratory system operating without thought or effort, orcas must actively decide when to breathe. Their breathing is voluntary, controlled by conscious thought rather than automatic reflexes. This means that even while sleeping, part of an orca's brain must remain alert and aware, ready to signal when it's time to surface for air. Sleep for an orca is unlike anything we experience. They practice what scientists call unihemispheric slow-wave sleep, where only half of their brain sleeps at a time, while the other half remains conscious and alert. Picture trying to take a nap while keeping one eye open and part of your mind focused on your breathing. It sounds exhausting, but for orcas, it's simply the price of living between two worlds. During these rest periods, orcas often swim slowly in formation with their pod, remaining close to the surface where breathing requires minimal effort. They'll sometimes float motionlessly for short periods, looking almost meditative as they hover just below the surface. But even in these quiet moments, part of their consciousness remains vigilant, monitoring their body's need for oxygen and coordinating the precise timing needed to surface and breathe. The physical adaptations that make this lifestyle possible are extraordinary. Orcas have developed nostrils that have migrated to the top of their heads, becoming the blowhole that allows them to breathe while keeping most of their body submerged. This blowhole is equipped with powerful muscles that can seal it completely underwater, preventing any water from entering their lungs during dives. When an orca surfaces to breathe, the process is remarkably efficient. The blowhole opens, old air is forcefully expelled, and fresh air is drawn in, all in the space of about half a second. They can replace up to 90% of the air in their lungs with each breath, compared to only about 15% for humans. It's like having a respiratory system that's been turbocharged for efficiency. But breathing is just one part of the challenge. Orcas must also deal with the immense pressure changes that come with diving to significant depths. As they descend, the pressure increases dramatically, compressing their lungs and altering the behavior of gases in their bloodstream. Their bodies have adapted remarkable mechanisms to handle these changes without suffering the decompression sickness that would incapacitate human divers. Their ribcage is flexible, allowing their lungs to collapse completely under pressure without causing damage. Meanwhile, they store extra oxygen not just in their lungs, but in their blood and muscles. Their blood contains higher concentrations of red blood cells than land mammals, and their muscles are rich in myoglobin, a protein that stores oxygen for use during extended dives. During deep dives, orcas can slow their heart rate dramatically, redirecting blood flow to only the most essential organs, the brain and heart. Non-essential functions are temporarily shut down, allowing them to maximize the use of their stored oxygen. It's like having a biological dimmer switch that can reduce energy consumption when resources are limited. Temperature regulation presents another constant challenge. Water conducts heat away from the body much more efficiently than air, which means that staying warm in the ocean requires special adaptations. Orcas have developed a thick layer of blubber that serves as both insulation and energy storage. This blubber layer can be up to 4 inches thick, providing crucial protection against heat loss in cold ocean waters. But blubber alone isn't enough. Orcas also use countercurrent heat exchange, a system where warm arterial blood flowing to their extremities passes very close to cool venous blood returning to their core. This allows them to transfer heat from outgoing blood to incoming blood, minimizing heat loss and keeping their core temperature stable even in near-freezing water. Living in salt water creates additional challenges that freshwater environments don't present. Orcas must constantly manage the salt content in their bodies, preventing dehydration while surrounded by undrinkable seawater. Their kidneys are incredibly efficient at concentrating salt and eliminating it from their system, while their digestive systems extract fresh water from their food. The energy demands of this lifestyle are enormous. Maintaining body temperature, powering the constant swimming needed to stay buoyant, and supporting their massive brains requires tremendous amounts of calories. An adult orca needs to consume hundreds of pounds of food every day, which explains why so much of their time and energy is devoted to hunting. Despite these challenges, orcas have not just survived, but thrived in their aquatic environment. They've turned the constraints of breathing air while living in water into advantages, developing capabilities that surpass those of purely aquatic or purely terrestrial animals. They can dive deeper than most marine animals while retaining the complex intelligence that comes with being mammals. Their success represents one of evolution's most impressive compromises, maintaining the advantages of mammalian biology while adapting completely to aquatic life. Every breath they take is a reminder of their ancestry, a connection to the land-dwelling creatures they once were, but also a testament to the remarkable adaptability of life itself. Long before humans built roads, orcas were already commuting. Beneath the seemingly featureless surface of the ocean lies an intricate network of invisible highways, traveled by migrating orcas for thousands of years. These underwater routes are as real and well-defined as any human transportation system, complete with preferred lanes, seasonal schedules, and traditional rest stops that have been used by countless generations. The ocean, to an orca, is not the vast, undifferentiated wilderness it appears to us. It's a landscape rich with landmarks, currents, and pathways that guide their movements across thousands of miles of open water. They navigate using a combination of magnetic fields, underwater topography, current patterns, and celestial cues that create a three-dimensional map more detailed than any GPS system. Different orca populations have developed completely different migration patterns based on their cultural traditions and food sources. The resident orcas of the Pacific Northwest follow relatively predictable routes that track the seasonal movements of salmon. During summer months, they concentrate around river mouths and coastal areas where salmon runs are at their peak. As winter approaches and fish populations shift, the orcas adjust their movements accordingly, following ancient pathways that their ancestors have traveled for millennia. These resident populations operate on what scientists call a circuit migration pattern, moving in roughly circular routes that bring them back to the same areas at approximately the same times each year. It's like having a seasonal schedule written in the very geography of the ocean, with different family pods taking turns using the prime fishing spots as the year progresses. Transient orcas follow entirely different patterns. Their migrations are less predictable, covering enormous distances as they track the movements of marine mammals across entire ocean basins. Some transient pods are known to travel from the frigid waters of Alaska to the warm seas off California, a journey of several thousand miles that takes them through dramatically different environments and ecosystems. What's remarkable about these long-distance migrations is how orcas maintain their family bonds while covering such vast distances. Pods stay together throughout their journeys, with multiple generations swimming side by side across thousands of miles of ocean. Grandmothers who have made these journeys dozens of times swim alongside young calves experiencing the route for the first time, creating a living library of navigational knowledge that spans decades of experience. The routes themselves are marvels of efficiency and environmental awareness. Orcas don't simply swim in straight lines between destinations. Instead, they follow underwater currents that reduce energy expenditure, time their movements to coincide with favorable weather patterns, and make strategic stops at locations where food is reliably available. It's like having a travel itinerary that's been refined over thousands of years to account for every possible variable. Ocean currents play a crucial role in these migration highways. Orcas have learned to read the subtle signs that indicate current strength and direction, changes in water temperature, shifts in wave patterns, variations in the behavior of other marine life. They use these currents like moving walkways, allowing the natural flow of water to assist their movements and conserve energy for hunting and social activities. The timing of migrations is often synchronized with the movements of prey species. Salmon runs, seal pupping seasons, and whale migrations all influence when and where orcas choose to travel. They've developed an intimate understanding of the seasonal rhythms of their food sources, positioning themselves along migration routes at precisely the right times to intercept traveling prey. Climate change is beginning to disrupt these ancient patterns in ways that highlight just how precisely calibrated orca migrations have become. Rising ocean temperatures are shifting the timing and distribution of prey species, forcing orcas to adjust routes that have been stable for centuries. Some populations are having to travel farther to find adequate food, while others are discovering that traditional feeding areas no longer support the abundance of prey they once did. The social aspects of migration add another layer of complexity to these journeys. Different family pods often coordinate their movements, meeting at traditional gathering places where multiple generations of orcas come together. These reunion sites serve as important social hubs where young orcas meet potential mates from other families, knowledge is shared between pods, and the complex social networks that bind orca communities together are maintained and strengthened. Navigation during these migrations requires skills that we're only beginning to understand. Orcas appear to use the Earth's magnetic field as a compass, detecting subtle variations in magnetic intensity that help them maintain their bearing across featureless ocean expanses. They also seem to use underwater mountain ranges, deep ocean trenches, and other topographic features as landmarks, creating mental maps of the seafloor that guide their movements. The precision of orca navigation is so impressive that researchers studying whale migration often use orca sighting data to understand ocean currents and environmental conditions. The whales have become living oceanographic instruments, their movements providing insights into marine ecosystems that would be difficult to obtain through other means. What's particularly fascinating is how migration knowledge is passed down through generations. Young orcas don't instinctively know these routes. They must learn them by following their mothers and grandmothers, gradually building the mental maps and environmental awareness that will guide their own movements throughout their lives. It's a form of cultural transmission that ensures navigation knowledge accumulated over centuries is preserved and passed on to future generations. The distances covered during these migrations are staggering. Some orca populations travel over 10,000 miles annually, crossing entire ocean basins and moving through the territorial waters of multiple countries. Their migration routes span from the Arctic to the Antarctic, from coastal shallows to the deepest ocean trenches. These underwater highways represent one of the most sophisticated navigation systems in the natural world, combining inherited abilities with learned knowledge to create travel networks of extraordinary complexity and efficiency. In following these ancient routes, orcas are participating in patterns of movement that connect them to their evolutionary past while adapting to the changing conditions of their oceanic present. Your smartphone has impressive sensors, but an orca puts it to shame. While we celebrate our technology's ability to detect movement, measure magnetic fields, and sense changes in pressure, orcas have been carrying around sensory equipment far more sophisticated than anything we've managed to create. They experience the world through a combination of senses so advanced and integrated that they can perceive aspects of their environment that remain completely invisible to us. Let's begin with their ability to sense magnetic fields, a skill that turns the entire Earth into a navigation system. Orcas can detect variations in the planet's magnetic field so subtle that our most sensitive instruments struggle to measure them. This magnetoreception allows them to maintain their heading across thousands of miles of seemingly featureless ocean, using the Earth's magnetic field lines like invisible road signs that point the way home. The exact mechanism behind this magnetic sense remains one of science's ongoing mysteries, but researchers believe it involves specialized cells containing magnetite, a naturally occurring magnetic mineral. These biological compasses may be located in their brains, their inner ears, or distributed throughout their bodies. Wherever they are, they provide orcas with a constant awareness of their position relative to magnetic north, creating a sense we can barely imagine. But magnetoreception is just the beginning. Orcas also possess extraordinary pressure sensitivity that allows them to detect the slightest changes in water pressure around them. This ability serves multiple purposes. It helps them gauge their depth during dives, alerts them to the presence of other large objects moving through the water, and may even allow them to predict weather changes by sensing atmospheric pressure variations transmitted through the ocean. Their pressure sensitivity is so refined that they can detect the movement of fish schools from remarkable distances, feeling the displacement of water caused by thousands of individual fish swimming in formation. It's like having an early warning system that alerts them to feeding opportunities long before their other senses would detect the prey. The hearing abilities of orcas extend far beyond what we've already discussed about echolocation and communication. Their auditory range spans from infrasonic frequencies below human hearing to ultrasonic ranges far above what we can detect. This enormous range allows them to eavesdrop on a vast array of ocean sounds, the low-frequency calls of distant whales, the high-pitched clicks of hunting dolphins, the subtle sounds made by fish swimming and feeding. Perhaps most remarkably, orcas can hear sounds traveling through the Earth itself. Seismic activity, underwater landslides, and even the movement of tectonic plates create low-frequency vibrations that travel through the ocean floor and water column. Orcas can detect these geological sounds from hundreds of miles away, giving them advance warning of environmental changes that might affect their territory. Their lateral line system, inherited from their fish-eating ancestors and modified for mammalian use, allows them to detect water movement with incredible precision. This system consists of specialized cells that respond to the slightest changes in water flow around their bodies. They can feel the wake left by other orcas swimming ahead of them, detect the movement of prey fish trying to escape, and sense the approach of other marine animals long before they become visible. Temperature sensitivity in orcas goes far beyond simple detection of hot and cold. They can sense thermal layers in the water column, detecting boundaries between water masses of different temperatures that are invisible to other senses. These thermal boundaries often mark important ecological zones where different species of fish congregate, making temperature sensing a valuable hunting tool. Chemical detection capabilities give orcas access to information that flows through the water, like underwater news broadcasts. They can detect and analyze chemical signals released by prey species, other orcas, potential threats, and environmental changes. Fear pheromones released by stressed fish can alert them to the presence of other predators. Chemical markers in the water can tell them about the health and reproductive status of other orcas they encounter. The integration of all these senses creates a sensory experience that we can barely comprehend. While we rely primarily on vision and hearing, orcas process information from magnetic fields, pressure waves, temperature gradients, chemical signals, and acoustic data simultaneously. Their brains have evolved to merge this flood of sensory information into a coherent picture of their environment that includes not just what's happening now, but what has happened recently and what's likely to happen next. This sensory integration allows for behaviors that seem almost supernatural. Orcas can track the movements of individual fish within a school, predicting where each fish will swim next based on subtle changes in water pressure, chemical trails, and acoustic signatures. They can detect the emotional state of other orcas from a distance, reading stress levels, excitement, and intentions through a combination of chemical and acoustic cues. Their ability to sense electrical fields, though not as developed as in sharks, still allows them to detect the bioelectric signatures of other living creatures. Every muscle contraction, every heartbeat, every neural impulse creates tiny electrical fields that orcas can perceive. This electrical sense may help them locate prey that's trying to hide motionlessly, revealing the betraying electrical signature of a living creature trying not to be found. During hunts, all these senses work together to create a kind of sensory overload that would be overwhelming for humans but represents normal perception for orcas. They're simultaneously tracking magnetic heading, analyzing pressure waves from prey movements, processing acoustic information from podmates, monitoring chemical signals in the water, and integrating thermal data about water masses, all while using echolocation to map their three-dimensional environment. The sensory world of an orca is so rich and complex that it challenges our understanding of what it means to experience reality. They live in a universe of invisible information streams, electromagnetic fields, and chemical messages that create a sensory landscape far more detailed and informative than anything our technology has achieved. In their perception, the ocean isn't empty space filled with water, but a richly textured environment full of information, opportunities, and connections that extend far beyond what any human has ever experienced. The ocean keeps its secrets, except from those who've lived in it for millions of years. Orcas are more than just apex predators or intelligent marine mammals. They're living libraries of oceanic knowledge, repositories of environmental wisdom accumulated across countless generations. In their movements, behaviors, and memories lies information about the health and history of marine ecosystems that scientists are only beginning to access and understand. Think of orcas as the ocean's equivalent of old-growth forests. Just as ancient trees hold records of climate patterns, natural disasters, and environmental changes in their rings, orcas carry within their cultures and traditions the accumulated wisdom of millions of years of marine life. Their hunting grounds, migration routes, and seasonal behaviors reflect deep understanding of ocean systems that predates human civilization by enormous spans of time. The matriarchs of orcapods serve as living encyclopedias of ecological knowledge. A 90-year-old female orca has witnessed patterns of ocean change that span nearly a century. She remembers where salmon runs were abundant during the drought years of the 1970s, which areas provided shelter during unusually severe storms, and how prey distributions shifted during periods of climate variation. This knowledge isn't just personal experience, it's institutional memory that benefits her entire family and, by extension, the broader orca community. Scientists studying marine ecosystems increasingly recognize that orcas serve as indicator species whose health and behavior reflect the overall condition of ocean environments. When orca populations thrive, it typically means that the complex web of marine life supporting them is functioning properly. When they struggle, it often signals broader ecosystem problems that might not be apparent through other forms of monitoring. The hunting patterns of different orca populations provide insights into prey abundance and distribution that would be impossible to gather through conventional research methods. Resident orcas that specialize in salmon can tell us more about fish population health through their behavior than years of fisheries surveys. When they begin changing their traditional hunting grounds or modifying their feeding strategies, it often indicates significant shifts in prey availability that have implications for entire marine food webs. Transient orcas serve as indicators of marine mammal populations across vast ocean areas. Their success in finding seals, sea lions, and other marine mammals reflects the health of these species far more accurately than sporadic wildlife surveys. Changes in transient behavior patterns, migration timing, or reproductive success often signal environmental pressures affecting entire categories of marine life. The traditional ecological knowledge held by indigenous communities often aligns remarkably well with orca behavior patterns, creating a bridge between human cultural wisdom and cetacean environmental knowledge. Coast Salish peoples, who have shared Pacific Northwest waters with orcas for thousands of years, have long recognized these whales as relatives and teachers whose movements and behaviors provide guidance about ocean conditions, weather patterns, and the availability of marine resources. These indigenous perspectives offer insights that Western science is only beginning to appreciate. Traditional stories and observations describe orca behaviors that scientists have only recently documented, including their role in regulating marine ecosystems, their responses to environmental changes, and their complex social relationships with other marine species. The convergence of indigenous knowledge and scientific research creates a more complete picture of orcas' role as ocean guardians. Climate change is creating new challenges that test the resilience of the ecological knowledge orcas have accumulated over millennia. Rising ocean temperatures are shifting the distribution of prey species, altering current patterns, and changing the timing of seasonal events that orcas have relied upon for generations. Watching how orcas adapt to these changes provides scientists with real-time information about ecosystem responses to climate change. Some orca populations are demonstrating remarkable flexibility in adapting to changing conditions. They're modifying traditional migration routes, experimenting with new prey species, and adjusting their social behaviors to cope with environmental pressures. This adaptability reflects not just individual intelligence, but the collective wisdom of their cultures, allowing them to draw upon generations of accumulated knowledge to navigate unprecedented challenges. However, other orca populations are struggling to adapt, particularly those with highly specialized diets or restricted ranges. The resident orcas of the Pacific Northwest, which depend heavily on Chinook salmon, face increasing challenges as salmon populations decline due to habitat loss, overfishing, and climate change. Their struggles highlight the vulnerability of even the most intelligent and adaptable species when environmental changes occur faster than cultural adaptation can accommodate. The pollutants accumulating in orca tissues tell stories about ocean contamination that span decades of industrial activity. Because orcas are apex predators with long lifespans, they bioaccumulate toxins from throughout the marine food web. Scientists can read the history of ocean pollution in orca tissues like reading chapters in a book, with different chemical signatures marking different periods of industrial development and environmental regulation. These pollution records held within orca bodies provide crucial information about the effectiveness of environmental protection efforts and the persistence of various contaminants in marine ecosystems. They serve as early warning systems for emerging pollution threats and living testimony to both the successes and failures of human environmental stewardship. The social knowledge held within orca cultures represents irreplaceable information about marine ecosystem functioning. Each pod's hunting traditions, habitat preferences, and seasonal movements reflect generations of trial and error learning about what works in their specific environment. When orca populations decline or disappear, this accumulated wisdom is lost forever, representing a form of environmental knowledge extinction that parallels the loss of indigenous human cultures. Conservation efforts increasingly recognize that protecting orcas means protecting not just individual animals, but the cultural knowledge they carry. This requires maintaining not only adequate population sizes, but also the social structures and environmental conditions that allow for the transmission of traditional knowledge between generations. As we face an uncertain future of environmental change, orcas offer both inspiration and instruction. They show us what's possible when intelligence, social cooperation, and deep environmental knowledge combine to create resilient, adaptive societies. They also warn us about the consequences of environmental degradation and the irreplaceable value of the wisdom that comes from millions of years of living in harmony with natural systems. In protecting orcas, we're not just preserving a charismatic species, we're safeguarding ocean guardians whose knowledge and presence help maintain the health of marine ecosystems that all life depends upon. Sometimes, when you stare into the abyss stares back with surprising intelligence. Looking into an orca's eye is one of the most profound experiences the natural world can offer, a moment when the boundaries between species seem to dissolve and we glimpse something startlingly familiar. A consciousness as complex and aware as our own, shaped by millions of years of aquatic evolution but recognizably similar in its depth and intensity. The comparison between orca and human intelligence isn't just poetic license, it's supported by remarkable similarities in our cognitive abilities. Like humans, orcas demonstrate self-awareness, recognizing themselves in mirrors and showing evidence of introspection and self-reflection. They display empathy, not just toward their own species, but across species boundaries, suggesting an emotional intelligence that transcends biological relationships. They engage in complex problem-solving, innovation, and cultural transmission that parallels the development of human technology and society. But perhaps the most striking similarity is how both species have used intelligence and social cooperation to become apex organisms in their respective environments. Humans dominated terrestrial ecosystems through tool use, language, and complex societies. Orcas achieved similar dominance in marine environments through echolocation, sophisticated communication, and equally complex social structures. We represent parallel experiments in evolution. two different pathways to advanced intelligence and social organization. The differences between our intelligences are as instructive as the similarities. Where humans excel at manipulation and tool creation, orcas have mastered integration and environmental harmony. Where we've used our intelligence to reshape our environment to suit our needs, orcas have used theirs to fit seamlessly into oceanic ecosystems while still achieving remarkable sophistication in hunting, communication, and social organization. Studying orcas has fundamentally challenged our assumptions about what intelligence looks like and how consciousness might manifest in other species. Their emotional complexity, evidenced by grief behaviors, long-term relationships, and empathetic responses, suggests that the capacity for deep feeling isn't uniquely human. Their problem-solving abilities, demonstrated through innovative hunting techniques and rapid adaptation to new challenges, show that creativity and ingenuity take many forms across different species. The possibility of meaningful communication between humans and orcas represents one of the most exciting frontiers in interspecies understanding. Current research using artificial intelligence to decode orca vocalizations could eventually lead to genuine conversation between our species. Imagine the implications. Learning about ocean ecosystems from creatures who've inhabited them for millions of years, gaining insights into consciousness and intelligence from minds that evolved along completely different paths from our own. Such communication could revolutionize our understanding of both intelligence and the natural world. Orcas might teach us about forms of knowledge we've never considered: how to read ocean currents with perfect accuracy, how to maintain social harmony across multiple generations, how to live as apex predators while maintaining ecological balance. They might share perspectives on time, memory, and experience that could expand our own consciousness in ways we can't yet imagine. The ethical implications of recognizing orca intelligence are profound and challenging. If orcas possess consciousness, self-awareness, and complex emotional lives comparable to our own, how does that change our relationship with them? The practice of keeping orcas in captivity becomes much more troubling when we consider that we may be imprisoning beings with rich inner lives, complex social needs, and sophisticated understanding of their environment. Wild orcas demonstrate behaviors that suggest they understand concepts of freedom, choice, and autonomy. They make decisions about where to travel, how to hunt, and how to structure their social relationships. They show preferences, form friendships, hold grudges, and display individual personalities as distinct as any humans. Recognizing this level of consciousness raises difficult questions about the ethics of human interactions with these remarkable beings. The future of human-orca relationships may depend on our ability to move beyond seeing them as resources or entertainment toward recognizing them as fellow conscious beings with their own rights and interests. This shift in perspective could lead to new forms of cooperation and mutual respect, perhaps even collaboration in understanding and protecting marine ecosystems. Climate change and ocean degradation present unprecedented challenges that might require the combined intelligence of both species to address effectively. Orcas possess detailed knowledge of marine ecosystems that could inform conservation efforts, while humans have technological capabilities that could help protect the environments both species depend upon. Working together, we might achieve conservation outcomes that neither species could accomplish alone. The study of orca intelligence also offers insights into the nature of consciousness itself. By comparing human and orca cognition, we begin to understand which aspects of consciousness are universal and which are specific to particular evolutionary pathways. This knowledge could inform our search for intelligence elsewhere in the universe and help us recognize forms of consciousness that don't conform to human patterns. In many ways, orcas serve as a mirror that reflects both our achievements and our limitations as a species. They show us what's possible when intelligence is combined with emotional depth, social cooperation, and environmental wisdom. They demonstrate forms of success that don't require dominance over nature, but instead achieve harmony within natural systems. As we face an uncertain future of environmental change and technological advancement, orcas offer both inspiration and guidance. They show us that intelligence can take many forms, that consciousness might be more widespread than we've assumed, and that the highest expressions of cognitive ability might involve not just individual achievement, but collective wisdom and environmental stewardship. Looking into an orca's eye, we see not just another species, but another form of being conscious, aware, and intelligent in ways that both parallel and complement our own. In recognizing their consciousness, we expand our own understanding of what it means to be aware, thinking beings in a vast and wondrous universe. They remind us that intelligence is not just about solving problems or creating technologies, but about living thoughtfully, loving deeply, and finding our place in the intricate web of life that connects all conscious beings. And so, we surface gently from the depths, carrying with us the echoes of whale song and the wisdom of the pod. We've swum alongside Earth's most sophisticated ocean dwellers, creatures who speak in dialects, hunt with strategy, and love with a fierceness that spans decades. From ancient wolf-like ancestors to the apex predators of today, orcas have written their story across every ocean, in languages we're only beginning to understand. They've shown us that intelligence comes in many forms, that family bonds can transcend species, and that the ocean holds mysteries as deep as space itself. Tonight, as you drift towards sleep, perhaps you'll carry with you the image of these gentle giants, patient mothers teaching their young, pods singing across the dark water, families staying together through storms and seasons. In their world of shifting tides and endless blue, they found something we all seek: belonging, purpose, and the comfort of those who truly know us. And if you found peace in this quiet journey beneath the waves, if the songs of the orcas helped your mind settle like sediment on the ocean floor, we'd be honored if you follow us for more gentle explorations of the natural world. Thanks for joining us here at Sleep Science. Sleep well, and may your dreams be filled with the vast, peaceful rhythm of the sea.